When we look at applications, okay, I even read this first one. Jennifer hit a golf ball from the ground and it followed the projectile to give me an equation. Where t is the time in seconds, h is the height of the ball, find the highest point that the golf ball reached and also when it hits the ground again. Now at first you're like, ugh. Then I think about it. Okay, what do I need? Now, I am not a good artist. I'm not even going to pretend that I am. So here's my grass. Yeah, there's my golf ball. Okay, so this golf ball, we're going to hit it, it's going to go up, and it's going to come back down, and it's going to hit the ground. Kind of looks like a parabola, kind of, sort of. So what do I need? Well, if we're looking for the highest point, you can kind of see how maybe a picture helps me here. We chatted a little bit about maximums and minimums before. We're looking for the maximum. And then we're also looking to see when it hits the ground. We're looking for the 0. We're looking for the x-intercept. And so here's why it's important to start recognizing what the pieces are and what their names are. Those are the names, zeros, maximum, that are on our help sheet. So once I know what it is I'm looking for, I'm really just going to be able to follow that. So what do I need? Okay, I need the vertex so I can find the highest point, the y value, and when that occurs, the x value. So let's make note of something here. So height equals my y. And think about the y-axis. It goes up and down, right? So that would make sense for it to be height. And when that occurs is the x value. The x value is going to be my time. So when I'm asked for time, we're talking x. When I'm asked about height, we're thinking about y. So find the x value of the vertex. What are my a and b values? So I know it's up above, but I'm just going to rewrite it here anyway, because maybe as we start moving, we may need it. So we've chatted a bit also about the number in front of my squared term is a. The number in front of my x, or in this case t term, is b. And the value on the end is going to be c. So when I go to find the x value of the vertex, I plug them into my mini formula, also on the sheet. So the opposite of b, the opposite of 100, would be negative 100, over 2 times a. Now here's the first place we can get ourselves into trouble if we're not careful. And a couple of you were watching as I talked about it a little bit on the board yesterday. If I don't watch how I put this into the calculator, I can get a really messed up answer, like 800. As some of you are typing in going, dang, how do you know what I got already? Oh, I know these things. So here's how you could get 800 and why, well, that doesn't really make any sense. So if I go to my calculator and I'm like, okay, I'm just going to type in what's here. Negative 100 divided by 2 times negative 16. Why am I getting 800? Because the calculator follows order of operations. The calculator says, hey, negative 100 divided by 2 is negative 50, and then multiply it by negative 16. You're like, that's not what I want to do. So here's what my suggestion would be. Take the two numbers below, down in the denominator. 2 times negative 16. Do that first. Then go ahead and do the division. You're like, ew, I like the 800 better. Okay? Yes, we can get decimals. This is real life stuff. Now, is there a way I could do it in the calculator all at once? There is, but it would take me putting parentheses around what I'm doing in the denominator. So I tell the calculator, hey, I want you to multiply these first, then do the division. I can still get there, but I still would suggest doing it in pieces, just so we avoid that problem. Okay, so that's the x value of the vertex. Y value of the vertex. Plug in your answer from step 1 into the equation and solve it. Okay. Y equals negative 16. When you get to the variable, we're going to replace it with the 3.125. So we definitely want to use the calculator here. Do the same here, where my t is. I don't even really need to put my plus 0, but I'll do it anyway. And then I type that just like that in the calculator. There's no little tricks with this one like there was with the x value before. So once I plug that in, I'm going to get another decimal number. Double check me if you would like. So what does this mean? Okay, I got this vertex. So what? Well, it asked me for the vertex. Let me write that down first. So what is my height? Y is my height. So 156.25 feet is how high the golf ball got at its maximum. Okay, how long did it take for that to get there? 3.125 seconds, because we're talking about time. Okay, so putting labels on things helps us to understand what the pieces are and what the pieces mean. So there's one other question. How long does it take to hit the ground? What's the x-intercept? What's the 0? Okay, those words are interchangeable. And here's where I've changed some things from last year, I think for the better. We're going to see. I'm not going to play this whole game with messing with the window and moving things around and, well, how do I know how to change my window? I don't know. Okay. Follow the yellow sheet. Okay, the yellow sheet is much simpler for what we're going to be doing. And like it says down here at the bottom, the x value, once I follow the yellow sheet, is going to tell me when the ball hits the ground. So if I bust out my yellow sheet, okay, finding zeros, finding x-intercepts. We are going to go into y equals. We are going to take that original equation, negative 16x squared, because we don't have a t to work with, plus 100x plus 0. Again, get practice with this because there really isn't going to be another option available. You wouldn't like the other option if I did tell you. So I hit graph. And all I'm doing here is I'm trying to get an idea. Okay, so this golf ball got hit. So what's this graph tell me? Well, if you think about it, if I hit the golf ball, unless I swung and missed, I don't think it's going to hit the ground that fast. So it's going to hit somewhere out here. So it looked like 1, 2, 3, 4, 5, like a little more than 6, something like that. But I need to know the exact value, and the chart's not going to tell me. So this is where I'm going to follow what I see here. So second, trace, and I want number 2. I'm looking for a 0. So this little cursor guy is going to show up. There he is. Blinky, blinky, blinky. So we are only going to be using the left and right arrows when we're doing this. So my job is to get this little cursor guy as close to that value there where it's crossing the x-axis as I can. Now this is going to drive some of you crazy at the start, but just stay with me. If I start hitting right to get over there, okay, my cursor disappeared. Don't freak out. Watch the y value. It's going to go up for a while. But after a little bit, it's going to start falling again. Pretty soon, okay, that's starting to fall again. Keep going. And pretty soon, my cursor is going to flop back into the screen here. Sometime. Aha! Now if I go again, oops, it went past. Let me come back. That's as close as I can get to the x-axis right now. Sometimes it's not going to be right on there. Okay, we just have to make an adjustment. So once I get there, notice, don't hit enter or anything yet. Number 4. 3 left arrow clicks. 1, 2, 3, and hit enter. And you'll notice there's this little tiny arrow and this really faint dotted line there. And what we're doing is we're creating a border. We're going to trap this x-intercept in. So to get our other border, we're going to go to the right. 1, 2, 3, back where I started. 4, 5, 6. Again, even if it disappears from the screen, it's okay. So now notice, I have an arrow here and an arrow there. And they're pointing at each other. They're saying, hey, the answer's in between the arrows somewhere. And it is. So now since it says guess, we're going to hit enter one last time. And the x value, 6.25, is my answer. X equals 6.25 seconds to hit ground. Use the yellow sheet. Because it's just the simplest way to go. The only other route I would have to find that zero would be to use the quadratic formula, which we haven't gotten into yet. Now, if you know and are comfortable with that, you can use that. But we haven't quite gone down that road yet. Okay. So as we do these, we're going to start finding some of the words in the background might be a little different, but the idea is going to be the same. So here's how this works. We got another one. Now we're going to do some fireworks. Some fireworks are fired vertically into the air from the ground at an initial velocity of 80 feet per second. You're like, what the heck is that? Okay. Initial velocity is always going to be, if it's there, the number that's in front of t. Okay? How fast is this going when I start? -16, if you're curious, just talks about gravity. Gravity doesn't change, so you're going to see that stay the same for these. This value on the end is where did I start? Oftentimes, it's going to be your y-intercept. That could come in handy sometime. So you're like, okay, where did I start? Some fireworks are fired vertically into the air from the ground. Okay, if it would have said from 10 feet in the air, I'd use 10 there. But I have to do a little bit of plugging in. I got to do a little bit of reading, but it's not going to be anything that's too bad. So once I have this, what am I looking for? Find the highest point, height, y, like the y-axis, reached by the projectile just as it explodes, the maximum, and when x value of my vertex, that'll occur. Now, maybe I need to draw a picture like we did with the golf one in the first example. That would be okay. But I just have to think through this a little bit. So, since I'm looking for the vertex x and y, find the x value of the vertex. Use the yellow sheet. So, x is a, b, c, the opposite of b, over 2 times a. And we learned our lesson from the last one. When we go to type this in, get that in there. And then divide them through. And yes, decimals, perfectly fine. This is real life. Not everything comes out even. Okay, x is time. So it took 2.5 seconds. My y value, go back to the equation. And any place that you see a variable, you replace it with your answer from the first part. I type that whole line into my calculator. I don't have to do anything cute. And I believe, nobody told me I did this wrong earlier, so hopefully somebody was watching over me there. So at 2.5 seconds, this firework's going to be 100 feet up at the ground when it hits its maximum. And that's really all I'm doing with these, is I continue to work my way through, but I just got to figure out what is it that I'm looking for. Okay, am I looking for that max? Am I working my way down? Yes, sir.
I got 2.5.
Oh dear, let's double check and make sure I didn't go cray-cray. If I can keep that glare out of my screen. All right. Did you put it plus 2.5 at the end? Good? Okay. Hey, that happens. I always want people to double check me because I do some goofy stuff sometimes. All right. So one more. Now this one's a little closer to 2. A ball is thrown vertically upward. Okay, there's my initial velocity of 48 feet per second. Ooh, but this time we have an adjustment. If the ball started from a height of 8 feet. Okay, it's not 0 this time. Determine the time of the maximum height of the ball. Ooh, and the time it will take for the ball to hit the ground. Okay, so I'm dealing with time twice, but in 2 different instances. The first time, I'm looking to see when the ball reaches the maximum, and the second time, I'm looking to see when the ball hits the ground. So either way, I'm going to run through those same steps. I'm going to take the opposite of my B over 2A. Again, take the time. Whoops, that didn't help me. Negative 48 divided by negative 32. 1.5 seconds to get to the maximum. If I wanted to know what that height was, might as well do it. We've got it here. I'm going to plug that value in for my variables in my original equation. Again, I just want to be cautious, make sure I get my negative in here, make sure I get my squared in, all that good stuff. Okay, so at 1.5 seconds, I reached the maximum of 44 feet. However, this time I want to know, when's the ball going to hit the ground? So this is when I go to my calculator to help me out. I'm going to go that original equation, this guy, or gal. I'll just look at the picture for a minute to kind of give me an idea of where the answer is probably going to be. Okay, right about there. So about 3 or a little bit more. So let's bust this back out. Second trace, I want number 2. All right, there's my cursor again. Got to get it over here. So I know it's going to disappear. Keep watching that Y. When it starts to come back down, I'll want to slow down a little bit here. Ooh, that's pretty close. Yeah, that's as close as I'm going to get. So as close to the x-intercept as I can get. Left. 1, 2, 3. Hit enter. There's my first kind of border, my first block in. Right. 1, 2, 3. Now I'm back where I started. 4, 5, 6. Enter. I should see the arrows pointing at each other, saying, here's my area, I'm going to be looking for it. And hit enter one last time. 3.16. 3.16 seconds to the ground. Again, not brutally awful. Just something I'm keeping an eye on. So we're like, okay, so far, height is Y, time is X. They're like, just leave it alone. I can't leave it alone. I never can leave anything alone. That's how I get myself in so many issues here. There's one more type we're going to look at. Then I really will knock it off. Same concept can be used to find profit for my business people. Profit from selling local ballet tickets. I don't know if I'd be doing that, but it is what it is. Depends on the ticket price. Using past receipts, okay, we got a function again, where X is the price of the ticket. That's important to know. So X is money. We want to find the ticket price. X value of my vertex, it just told me X is the price, that gives the maximum profit. Price I charge, money I make. Just watch the dollar bills stack up, just like the y-axis, and find the maximum profit. So how I'm going to go about it's no different. I'm still opposite of B over 2A. Multiply these first. I get negative 30 and put that into my calculator. I get 20. What does that mean? It means that's my ticket price. So to maximize my money for my tickets, I should be charging $20 a ticket. 19 won't get me there. 21 won't get there. It's going to be 20. So how much money is that going to put in my pocket at the end? Plug it into the equation. Anytime we see the variable, in goes 20. And once I get it in, I go straight to the calculator. Let the calculator do all the work, because I'm more interested in how much money I'm making. And I find out the best I can hope for with my profit is a little over $6,000. It's not bad, not bad. Hold this close this first day that we're doing some of this stuff to kind of give some guidance, because the worksheet we do tomorrow is going to repeat some of these different things again. We'll still be using the yellow sheet. We'll still be playing with it a bit. But I want to make a couple of quick comments and adjustments as far as the worksheet goes. So let me pop the worksheet up here for a second. Okay, so this is the actual homework. We are going to be skipping 2C. That is not a topic we've covered yet when we're not looking exactly for the maximum, how to make that adjustment, so we're not going to go down that road. And then just as an FYI, when you get to the back, yes, Harty actually did mean to cross out B. But there is one problem on here I want to do with you. Down at the bottom is a review of something we did last week. I want to kind of go back over it again because the graphing in this form are going to come back. So I'm going to go down to number 5 here. It says determine the equation in vertex form of the graph shown below. So to do this, I even made a note here. We need to know what A, H, and K are, but we know that H and K come from my vertex. So I have that already. There's my H and K. So the only thing I really got to figure out is A, which is my, remember, air quote, slope. So my A, I know a couple of things. First, I know it's positive. I'm opening up. If it opens down, I know it's automatically negative. So slope is rise 1, 2, 3, 4, 5, 6, 7, 8, 9 over 1, 2, 3. And if I can reduce it, I should. And in this case, I can. 9 divided by 3 is 3. So I got everything I need. I got H, I got K, I got A. Let's do this. Y equals A, X, opposite of H, opposite of 3 is negative 3. And the plus K just means leave K alone. Okay, so you've got one to do as well. Now, you'll have noted on your homework check, there's still a couple more things coming your way here. A couple things tomorrow. There'll be one thing Thursday as we're going through the review. So keep working with these, because the more practice you get, the better you're going to do on the quiz, and then it's less likely you've got to do a retake and then start doing a bunch of homework if you didn't do it. Especially, we got about 15 minutes to play with here. With this number of problems, we should be done before we leave. So if you got questions, let us know, but try them and check them first. Okay, use your tools.